Hello everyone, I'm He Tao. The author of this paper are unable to attend the meeting, so they have entrusted me as a substitutor to complete this presentation. I will introduce their research on fast radio map construction. As we all know, dense RS collecting is time-consuming and labor-intensive. For example, one of our testing sites have 475 RPs. It costs about 8 hours to finish that survey, so it is critical to reduce the construction and maintenance cost. The deep radio map super resolution method are usually used in the radio map updating and achieving process-lay reconstruction results. However, they are not suitable for initialized or fine-grained radio map due to the locking of new set pairwise data. So to figure out the mapping of cost to fund for efficient radio map reconstruction, we represent the radio map as a several heat maps to resolve the correlationship of RPs. As to say, based on the historical heat maps in source domain, we attempt to find the mapping function M with parameters to accomplish the super resolution of the heat maps. Then our goal is to apply the mapping function M to the target domain precisely. To achieve the knowledge transfer between domains, we employ domain adaptation theory to minimize the uniqueness of each domain with domain invariant features FDI. Meanwhile, knowing that floorplan varies from different sites, so we adopt floorplan as domain-specific features FDS. Afterwards, we used FDI and FDS. Thus, the two features are treated as the input variables of mapping function, which makes the construction problem general for different sites. Logically, the framework has weighted domain disentanglement modules, since constraint super resolution modules, and recovery examination module. First, the domain disentanglement module adopts an adversary structure to learn domain invariant features. And next, the since constraint module, the fused features are passed to a constructor for heat map super resolution and the restriction of floor plans. Last, the recovery examination model aims to minimize the information loss during low resolution features after being divided to two parts. To better transfer super resolution mappings of source domain to the target domain, to learn, we realized a feature extractor EDI to learn domain invariant features FDI for mapping. Meanwhile, we leverage a domain identifier D, which takes FDI as input and output the domain label T. Since the floorplan is an x-axis and specific features for a site that disturb the various signals while propagation, we take the floorplan as domain-specific features to boost the construction accuracy. These features show the structure of a super resolution module. First, we employ a floorplan feature extractor EDS which have a similar network structure to ED. After that, we take FDI and FDS to be variable of a mapping model. Then, the uniform constructor can be transferred to other domain adaptively. And for experiments, we carry out density surveys at 4 test sets in campus. Besides, we also adopt a public data size, which was collecting in an area among several bookshelves of university library. This table shows the details of 5 data sites, which include 3 different layouts, both large or small area since are covered. And the results and our experiment evaluate the construction accuracy and the localization accuracy with this evaluation metrics. Here we present some experimental results. First, this group of features describes the modification to features caused by domain disentanglement. In feature A, the features synthesized with domain and are unlike other domain. On the contrary, features in finger B are evenly distributed after domain disentanglement, and we show the alignment of local features in finger C. Secondly, we compare the construction accuracy with the other 6 methods for a state-of-art reading map construction algorithm, and the other 2 are transfer advisory learning method. The table shows that we achieved an average improvement about 18%. So here comes the conclusion. Firstly, we present the reading map construction framework with transfer learning, aiming to construct a funky-end reading map with partial ISWC in a new site based on learned knowledge from other sites. And secondly, we design a weighted domain disentanglement network to align source domain in the domain-invariant latent space and adapt to target domain. Hence, we achieve successful transfer of construction model between domains. And finally, we proposed a since-constraint super-resolution method by using the set explicit and domain-specific features extract from the corresponding floorplan. The construction model's transferability is boosted. So that's all. As the authors of the paper are not present, so please feel free to email the authors with any question. Thank you.
Okay, thank you very much for your presentation. Okay, it's time to start the panel session. So all the presenters, please come up on the stage with a chair. Yeah. Okay. Thank you again for coming to this session.